To solve an equation with radicals, I have to first isolate one of the radicals. All right, so let's isolate that square root of 2x plus 6. So I'll add the square root of x plus 4 to both sides of that equation. That gives us the square root of 2x plus 6 equals 1 plus the square root of x plus 4. Then we'll square both sides. On the left side of the equation, if you square a square root, it just undoes it. So I'm left with 2x plus 6. But on the right side of the equation, what I have is a binomial. When you square a binomial, use the special product. Square the first term, so 1 squared is 1. Multiply the two terms together and double it. So 1 times the square root of x plus 4 is just the square root of x plus 4. If I double it, I have 2 times the square root of x plus 4. And that sign. Plus the square the last term. Well, if you square a square root, it just undoes it. So square the square root of x plus 4 is just x plus 4. So collect like terms. So 1 plus 4, that's 5, plus x plus the 2 square root of x plus 4. So I still have a radical in the equation. So I need to isolate it. I'll subtract 5 from both sides, x from both sides. I'm left with x plus 1 equals 2, the square root of x plus 4. So once I've isolated the radical, I'll square both sides. So on the right side, if I square it, I have to square each factor. So 2 squared is 4. The square root of x plus 4 squared, we'll just undo it. So it's times just x plus 4. On the left side, I'm squaring a binomial. So I'll square the first term, multiply the first and last terms together, and double it. So 1 times x is x, times 2 is 2x, plus square the last term. So I'll simplify it by distributing the 4 to each term inside the parentheses. So I have 4x plus 16. So we have a quadratic equation. I'm going to set it equal to 0 and solving it by using the zero factor theorem. So I'll subtract 4x from both sides and 16 from both sides. So I have a quadratic equation equal to 0. So using the zero factor theorem, I need to factor this expression. So x times x is x squared. And I want factors of 15 that subtract to get 2x. Well, 5 times 3 is 15. And the difference between 5 and 3 is 2. I want it to be a negative 2, so I'll make the larger number negative. So negative 5x and a plus 3x gives me that negative 2. So then I'll set each factor equal to 0. So I have x minus 5 equal to 0, x plus 3 equal to 0. So x equals 5, x equals negative 3. These are only possible solutions to the equation. We have to check them if we're working with equations that have a square root in them. We have to check. So if x equals 5, replacing each x in this equation with 5, have square root of 2, replacing x with 5, plus 6, minus replacing x with 5, should equal to, I'll put a question mark, 1. Well, 2 times 5 is 10, plus 6 is 16, so the square root of 16 minus the square root of 9 equals 1. Well, that is true. Square root of 16 is 4, minus square root of 9 is 3, equals 1. So, x is 5 is a solution. Now let's check x equals negative 3. So 2 times negative 3 plus 6 minus negative 3 plus 4 should equal to 1. So negative 6 plus 6, that's 0. And the square root of 0 is 0. Negative 3 plus 4 is 1. So the square root of 1 is 1. Well, 0 minus 1 does not equal to 1. So we would have to throw that possible solution out.